Guys, my name is Ojash Shrestha. I'm the founder of Neplopers Inc. And today I'm here to talk about some machine learning stuff and deep learning stuff using the service on Amazon called Amazon SageMaker. So here we learn about how to implement sentiment analysis technology reviews. So we'll have a data sets and try to test it, and we can find out how accurately our model works for this movie review. Right. So let's go ahead to understand what we are talking about. Let's go to the big picture. Right. It's all about artificial intelligence that started a few decades back, and this artificial intelligence was mainly designed in a way back then as generic system so that you could like use artificial intelligence in different fields. So artificial intelligence basically means giving the computer the intelligence of human beings. But as of now, we have tuned artificial intelligence to such extents that we are focused in specific subjects, right? Specific key elements, specific fields. And now there are artificial intelligence that have surpassed human beings and the capabilities of human beings in certain extent. So under artificial intelligence, we have machine learning, right? So machine learning is basically this way of giving data to machine so that it can learn itself. So we feed a lot of data to machine and we build models out of it, right? And we test how accurate the machine is. So more the data we have, the more better data we have, the better the machine can be trained and we can like function different use cases out of it. So inside machine learning, deep learning is there, and deep learning has changed how computers and how we use the world today, from Google search engine to everything out there, right? So multiple levels of neural networks that actually act as human beings' new brain, right? So the word itself comes from neurons from human's brain, and using the deep learning, we can actually implement such things that regular programming could not, right? So in traditional programming, what we had is we just had these if and if else cases that we just use in order to, for example, if it's raining, carry an umbrella, right? So that's very basic. So if you've got 1,000 different test cases, different 1,000 different cases, how are you gonna be able to like use that with traditional programming? You cannot. So that is where the artificial intelligence came in, machine learning came over the years, and deep learning has come recently, and it's changed how we use technologies today. So regarding the sentiment analysis, right? So sentiment analysis, as the word itself says, it's more about using NLP, using text analysis and biometrics to understand how the sentiments of people are, right? So, for example, you can take in as Twitter, right? So, in Twitter, there are thousands of tweets people are pushing in every single day, and you see some we are actually implementing a machine learning model to analyze how we can extract the sentiment from these texts. Right? So, for example, currently there's war going on, that invasion going on from Russia on Ukraine, right? So, what's the sentiment of people? And let's say, for example, for this, how does this affect in global scenario in different fields? Let's just take example of stock market, right? So, if there is war, what the stock market is gonna react like? It's gonna get negative, right? Because you just do not know. People want liquid cash, right? So using sentiment analysis, using this text, so we build this machine learning model and we train it, and then we analyze the new text that's coming from Twitter, right? And how's the sentiment of people? What are people texting? Is it positive? Is it negative? How is it, right? So the war thing, the negative reviews, the negative aspects of the global scenario can actually get this global stock market down. So how fast you can react to these sentiments can actually make you big profits or loss in or trading in stock market. So sentiment analysis can also be used in different scenarios, from market research to branding to a lot of stuff, right? So we are gonna specific talk about movie review on sentiment analysis today, and I'm gonna show you how it's done. And yes. So regarding the algorithms that are used for sentiment analysis, there are different ways that we can do sentiment analysis. We can use different algorithms. So for example, we have XGBoost, right? It's this combination of using bagging and random forest and boosting algorithms to merge it into a way how we can fine tune our machine learning models. Like XGBoost has been using Kaggle, and a lot of competitions have been won using XGBoost right now. As there's support vector machine SVM, so there's this support vector machines can actually be used for stock market trading analysis too. Though there is this um, hypothesis that stock market cannot be actually predicted, but a lot of companies out there are focused on this. Like for example, there's a company called Renaissance in the US. The investors have been able to return over 30% of CAGR in last 20, 30 years, and that's made him like over billions of dollars, right? So as I talked about the neural network, the recurrent neural network can be used for something analysis. Convolution neural network can be used. Random forest, naive Bayes. So I guess a lot of people who studied computer science in school, in the universities right now, they would obviously have heard about the naive Bayes algorithm and a lot of mathematics that goes behind naive Bayes. I guess you have obviously heard it. There's also this LSTM, short-term memory. These algorithms, all of these, right? We can use any of these in order to use it for sentiment analysis. So next is like today we are going to talk about the neural network, right? So neural network is basically this form of using multiple layers of black boxes, let's say, right? And we are going to pass our input data into it, and over different layers, it's going to process just like our neuron, like how our brain functions, like, right? So we are going to use that, and out of it we are gonna we're gonna get the output, and the output that comes from neural network is usually a lot better than specific single hand algorithms like naive Bayes or those. But you need to remember that it really depends upon what you're using for, and the case scenarios too. So a lot of artificial intelligence can, from natural language processing to image recognition, neural network has come really handy on it. And yeah, even Google search algorithm uses neural network, and it's the reason why we can like get our output of web ranks of in our Google like, in milliseconds, right? So neural networks like really huge out there. And just as I said, like deep neural network, you've got these input layers, you've got multiple hidden layers. Like each of these single vertical layer have a different task, right? You take in input from the previous layer and you process it to a certain extent. And but between like these hidden layers have the processing, and at the final output layer, you get your output results. So and these have been in use, and these are like the state of art right now, from Google to all of these FANG companies. They use meta learning today, like deep neural network today. So one of the test case scenario for machine learning or sentiment analysis is Netflix, right? So in our schools, we've always studied in a way that what's the benefit of studying, like why are we studying these things, right? So we just do not actually get in tune to it. So machine learning is so useful, and is to make these multi-billion companies, like these use companies, billions of dollars, right? And how do these machine learning actually apply in the real life, right? How do these machine learning technologies make Netflix, Microsoft, Facebook these billions of dollars from ads in Facebook and Google to Netflix itself? So one, we have Netflix uses machine learning to determine which thumbnails you have the highest chance to click on. So what machine learning of Netflix does is all these curated, all these what do you call, videos of series and movies that Netflix have on this arsenal. What should it present to you on your screen that you are gonna like it? And what's the thumbnail if they have, are they gonna see it? So you need to see that people of like there's different market segments, right? From people who are aged 16 to 24, and the people who are over 60, and people who are like 40 to 50. All of these are different preferences of what they want to see. Like for example, your dad reads a lot of newspaper maybe, right? So your dad may be interested in documentaries more than you. You might be interested in something like Emily in Paris, right? So a lot of fun stuff, right? So, and what does the thumbnail like? How what thumbnails can actually garner people to click on it. So if you see the banners, if you see the thumbnails of Netflix, depending upon different accounts of your friends and your families, depending upon your age and what you've watched previously, the thumbnails change, right? And that thumbnail is specifically designed for you and specifically for you to like click on that and like test how these videos on Netflix are. And you know how binge watch is in Netflix. Like once you start on a series, you are not gonna finish it for like you're not gonna like just drop out. You're gonna watch the entire series, at least the first season itself, right? And that actually makes you tune in to like buy more subscription from Netflix. Next is buffering, right? So you know, during different times, for example, in August, let's say March 1 is coming, right? So March 1, Netflix is gonna give out five more new series, right? So this machine learning algorithms predicts how the subscription users are, like when should they be like launching new stuff, right? And so, and at what time are these servers gonna like be loaded? So a lot of machine learning goes into like to make sure that the buffering on your system does not occur, right? And a lot of algorithms that are used to predict how the viewing patterns of these people are on of Netflix subscribers. It's up there. So next is also about how Netflix uses what should they be integrating in the content, right? So depending upon machine learning, like using machine learning from what shows people watch and what of these series has got more better reviews on cinematography itself or direction itself or locations itself, right? So knowing which location would the audience prefer, Netflix can say, okay, we are going to shoot this series on this specific location, or we are going to integrate a part of these continental views, these countries views, or from these mountains or these deserts to integrate in our series of this, right? So Netflix is using machine learning to actually find that out. And moreover also about the market fit, like what specific content would you like what content are people rewatching, and Netflix can see like what part of the series are you just like watching in like 4x, right? Because you don't want to watch that part, you want to watch the good part, right? And what you want to watch, Netflix is keeping track of that. And just as my previous speaker said, Sudeepji said, a lot of these data just are like taken in like there's a store and it's on the data warehouse, and they use these data from data warehouse, they process it a lot, and they later use it into machine learning to make sense of this data, right? So a lot of machine learning is integrated into Netflix system, and that is why Netflix has been able. That is one of the key reasons why Netflix has been able to go so huge. Like it has been able to like be in people's home across continents, right? So understanding how machine learning can be used in business applications or in your real life can actually help you, and also help you become a better, like be interested in programming or machine learning itself, right? So and regarding how we actually implement, like for example, sentiment analysis, right? So how would we integrate sentiment analysis for our text? Like for example, we have these reviews from people, right? So all of these, for example, first of all, we are gonna have all of these data, and from all the data we have, we are gonna, like for example, divide it into like 80 to 20. Like that is one of the good rules. Using 80% of data to train our machine learning model and 20% to test it, right? And make sure that you never use the testing data to train your models, right? Because that's gonna create an issue later on. Like the accuracy would be high, but you're gonna either overfit your data or underfit in a way. So make sure that you divide it into like 80 to 20 or 70 to 30 for machine learning, right? And for example, these let's say 80% of data, we use 80% of data to actually make a bag of words, right? So out of all the reviews that are out there from the data set, we used to create these bag of words. Like for example, each words we are going to use, like for example, you can see over there from the document, the quick brown fox jumped over the lazy dog's back, right? So from these multiple documents, it it lists all of these data, right? And which document has which terms. So we are gonna give 0 to the data that's to the term that's not there in the document at 1, and we are gonna make this huge sheet of words, right? So this is basically the bag of words, and this is what we later use to find the sentiment and like understand these words, like which of these words, if they are used in our text, like in the review from the customer, that's gonna be negative or positive, right? So bag of words is one of the integral part of sentiment analysis in any of these algorithms. And you need to know that 85% of machine learning models in today's scenario barely make it to production, right? Like people make their machine learning models, and it's like they spend so much of time, and not just time, they spend so much of resources, like from these engineers and data engineers to data scientists to a lot of services that they use, like they may be using Azure for it. They may be using like the Azure's machine learning studio or Synapse, like Synapse Studio of Azure itself, from to Amazon's AWS services, right? So Amazon have multiple services. For example, Amazon SageMaker that I'm going to talk to you right now, and in this webinar, and a lot of other services too. So learning about this entire process of how machine learning happens is quite integral when you start itself, right? Like first of all, get the big picture of how machine learning is done, because unless and until you know how the entire framework works, like just being a part of the big engine, like this big monumental engine, and like just know the big small part of it, it's gonna be very difficult for you to like understand how what you're working on actually makes sense and like is used by the other engineers or other team members in your company or your project, right? So how do you actually do that? So first of all, you need to learn about the machine learning workflow itself. So machine learning workflow can be kind of divided into, like, let's say three parts, right? So the first part is like data preparation, right? So you have these data sets. First of all, you get the data sets like that are either freely available, open source available, or you are getting data sets from your clients mainly, right? So what you have to do is, first of all of these data needs to be cleaned and they have to be explored, right? So as my previous speaker has already said, a lot of these parts are also done by data engineers, and also you as a machine learning engineer would need to know how these cleaning are done, and like if you've got all of these missing values or empty rows and columns, you need to kind of make sure either you're going to integrate that or not, right? Because those are going to create anomaly, like outliers. Those are going to create all of these anomalies, and that's going to actually hamper your machine learning, right? So if you actually use a data set without cleaning, without processing, the machine learning model is not going to be that quite accurate, right? So once you have done that, then you transform your data set, and then you actually train your model, right? So you train your model on this data. It's like, just as I said, like 80% of the data set that you have is used for training. And after that, once you train it, then you can actually use some hyperparameters tuning, right? So you can tune your hyperparameters to actually get a better accuracy on your model. And then once you tested the model, like the 20% of the data set that you have, you use it to test the model, and you supply those data to actually find out if the output of these data are like accurate or not, right? And once you are like good enough and happy with your machine learning model, then you can deploy it to production. So when you deploy to production, this is like there's this entire scenario that comes up, right? So if you're a software engineer, you always heard about this DevOps, right? Like like developing and operation is like it comes together. So in machine learning itself, there's something similar called MLOps, right? So when you have these data, like for example, you use data sets of like, let's say 2 years ago, okay, and what happens is you train your model on the data set that's like 2 years ago, and now for current scenario, you deploy your model, and the new what do you call your clients or your users, your customers are using your system. Now what happens is, over time the patterns of use cases change, right? For example, let's say the audience of Netflix might be the initial market target of Netflix might have been between the age of 16 to 30, right? But later on, Netflix have been started to be used by around people of 60 and above, right? So so what you can get out of these clients, so what the data that these audience show are going to be different. And if you are using the data sets that was really good for these clients of 16 to 30 age, might not function well to predict what the use case scenarios or what these people of 60 and above are gonna like. So just say about the thumbnail thing that I expressed before. If you are testing all of these thumbnails from data which are used for the 16 to 30, that was like really good for it. That was like it kind of becomes an overfit for people who are 60, right? So you need to like have this operation over and again and again. So MLOps comes really important, and for this there is a service that's out there in Amazon, which we knows as Amazon SageMaker, right? So Amazon SageMaker has this entire end-to-end technology that can actually help you use machine learning, from data preparation, from using the data set to your live, to your notebook itself, to developing all of your machine learning codes, and like implementing it, training the model, right? And then testing it. And then you can use other services, right? For example, the Amazon Lambda, for example, to trigger event to your from your machine learning model. And then you can use the API gateway of Amazon itself to actually get data. Like for example, if you're using a web browser, if you have a web app, and like we are trying to integrate this machine learning itself, and you, for example, give an input to data to a website, and you want to get an output from it, that actually happens to the API gateway itself, right? So Amazon Gateway, Lambda, all of these comes handy, and it's an important part of the entire machine learning process itself. So as you see, you've got this app, for example, right? So you've got an app, for you have a browser, and there you, for example, there's a part where you send your review, right? And that review part would actually go to the API gateway, and that API gateway will trigger, okay, trigger the Amazon Lambda feature, right? Because it's serverless and it just like works on trigger. So you set your trigger for your Amazon Lambda for the API gateway, and then the API and the Lambda service will actually use your model to actually give the output to the API again, and that will actually give you the result for your for whatever like your machine learning output you've been asking for. So next is like the demo, and for example, this is a easy like for example, is your review positive, negative? Like you have this form where you just type in, this movie was amazing, I couldn't believe how incredible it was, I enjoyed it very much. So just like typing this, this input from the web browser will give that data to the API itself, right? And then that will trigger the Lambda, then it will go to the model, and the model will give you an output, right? And that through the that output through the Lambda will be sent to your web app through the API, right? So this will actually, like, the last output that's triggered is like, once you submit, your review was positive. And if that review, for example, this movie was negative, terrible, I don't recommend it at all. So that's gonna be negative review, right? So let's see how Amazon SageMaker actually works with it, right? So I'm gonna take you to the Amazon's web page, right?
Just to
yes.
inform, we have more 10 minutes.
Oh, sure, Dada, sure.
Thank you.
So basically, this is the Amazon web page, right? So over here we've got Amazon SageMaker service, and we have Amazon SageMaker, right? So one of the service that Amazon provides from all the different services, the machine learning itself, there's like services like Amazon Comprehend, which actually gives you the sentiment analysis itself, right? So instead of that, if we use Amazon SageMaker, this is going to give you the end-to-end process that we train our model itself, we prepare our data, we test it, and then we have this end-to-end reach for our system, right? For example, in Amazon SageMaker, we've got ground truths, like where we label our data. All these data sets can be labeled in our ground truth, and under notebooks, like for example, notebook instances, right? So this is where we deploy our the buttons of Zoom is like disturbing my process, right? So we've got so from notebook instance, we create our notebook, right? So I've created a notebook called my notebook, and it's in service right now, right? And in this notebook, I have different service, like different web app, like different documents, different notebooks that I have, right? So this is where the Jupyter itself is embedded into Amazon SageMaker. So these notebook instances, like the Amazon SageMaker gives that functionality to run your notebook into Jupyter notebook into Amazon SageMaker itself, right? So if you get inside it, so let's get around SageMaker itself first. So we've got these processing jobs, we've got training jobs. So we can train, like we can get the output of all of these training jobs that we have done. It's all listed in, like, these are the previous training models that I did, right? Modeling that I did, and like hypertuning can also be listed, and like you can see all of these inferences of different models that are in use right now, right? So when you create this, when you test your train your data, and like you are done with your testing, then you can deploy all of these models, right? And the endpoint can be created for you to use it, to attach it to whatever web app or like mobile applications, wherever you want to use your service from, right? So all of these services are like all inclined, all embedded, all within Amazon SageMaker. So if we get inside our model, right? So we've got this entire notebook of machine learning for our sentiment analysis, right? So what we do over here is we first of all, wow, this is getting slow. Yeah. So here, what you do is, like, first of all, we there's like this generic outline of what we're going to do. So we are going to download our data. We are going to process and prepare the data for us to train it, right? We upload it to the S3 bucket of Amazon. So we are going to use this another service called S3 bucket of Amazon to upload our data, right? And once that's uploaded, like, that's what we're going to use to train our model. And then we are going to test our model using the patch transform. And then we are going to deploy this train model to our deploy this training model, and that deployed model, that's like from the endpoint that I just showed you, this from this service on endpoint, this is what you can like use in, right, in order to your web app. So for example, if you've got this simple web app where you have this where you have this post, right? So you can, all you have is under your form action, you just call this productions um, gateway, right? So for example, you've other services like the Amazon Lambda, as I spoke earlier, right? And Amazon Lambda and Amazon API gateway, right? So you use the services, for example, the Amazon, we create this Amazon Lambda to trigger our thing. And for example, from this code that we have, I've done this entire processing, right? So what we do is, like, for example, we've got this, and this is, I've already deployed it, right? So if I configure, here we're just sending a body of what a waste of time, he did the movie, not like in any form, right? So if I do that, I can just like use it, and I can just test this, right? Yeah. So what it gives is the body output is 0. So what you need to understand is sentiment analysis output is basically from 0 to 1, 0 being the most negative and 1 being the most positive, right? So if we do this test on this positive review, which is basically, if you see, I've written the positive is like, what a waste. Oh, sorry. The positive and the positive configure. I absolutely love this movie, right? Just fantastic. And I will just do this. Um, was great. And if I'm gonna test it on pause right now, so it gives 1, right? So this is basically the review that I just wrote over here. It's like fully positive, right? So this text, absolutely love the movie, just fantastic. How better can it be? It's like, it's 100% accurate. So 1 is basically 100% accurate that your review was positive, right? So, and that is what you actually use to call upon your website. And for example, we've got this website over here. So, yeah, so we've got this website over. If you go to this one movie, and if you type on in your review and hit your submit, you can just like get in your review, right? All right, into service error. So demo something sometimes happens like that. But let's get back to our notebook, and I just like to take you to this quick review of our project, right? So for example, first of all, what you do is like we install our SageMaker to our notebook itself, and then we download the data, right? So we are using the data from the sentiment analysis data set that's available, that which was from this 2011's 49th annual meeting of the Association of Company Linguistic Human Technologies, right? So I'm just using this IMDb's data set. So this data set is all full of different reviews for different movies, right? So I just download. This is where we download to the Amazon's S3 bucket, right? And once we download it, we actually process it, and we like train it, like we process, like we prepare this data set for training and testing, like we split the data, and then we actually, like for example, like this is where we have done it. We've taken 15,000 for positive, 15,000 for negative, right? So the training and testing, all of these data in there. And what we do is like we shuffle all of these data so that we can now do the operation of and like again see how these training and testings are done, right? So we are basically using, like from this review, we've got around 25,000 data sets that's up there, right? And for example, one of this data that we can actually, let's see, just see is like from the hundredth data from the data set we just like stored. It's like I have screened this review. This is one of the data from the data sets that we just like imported to our S3 bucket, right? So I have screened this movie several times. So things like these, like huge reviews from different people, we actually use into to actually use to train our model, right? So now what you do is we use Beautiful Soup, basically this library that we have, in order to make sure that we have all of these. For example, this sentence we have a capital I, we've got dot dot dot, we've got commas, we've got all of these apostrophes and all of these semicolons and all of these things, right? And the single words and brackets, we need to remove this before we actually use it to like train our data, right? So what you do is like we actually we use this Beautiful Soup to clean the data, and then we separate all of these single words, right? To screen, movie, severe, time, college. So we use this Beautiful Soup to get these different single words out of this very text that we had, right? And this is the text from the above one data we had. So similarly, from different reviews, we are gonna do this in when you train it, right? And then when you've done that, now we can like just process it and like we save it to this cache file, and this is like this is just saved over there in our Amazon SageMaker itself. And now we need to transform this data, right? Like we need to transform into the bag of words itself. So these were the bag of words, right? But now we need to find out in the bag of words that I just wrote the array of which words are there, which words are out there in this big bag of words that we have, right? And when we just like do that through this, we are creating this vocabulary size of 5,000 words, right? So from all of these data sets, we're creating this 5,000 words bag of words. So like the top 10, like let's say the 10 data are like these, right? And these are all of the words, like you can see how huge this is. This is 5,000 words from all of the data set that we created the bag of words for, right? And we are gonna, if we see this over here, it's gonna be huge, right? So 5,000 words over here and from the data sets. And now we see how often all of these words are repeated, and we actually train our model, right? Now we list what are the most common words, right? So one of the common words, frequently common words, are like movie, film, one, like, it, time. Like you can understand why these words would be really in use, right? These are like the most frequently used. Why? Because all of these reviews, if you count the number of times all of these words have been used, like it's really sure that one of the best movies I have watched, one of the worst movies I watched. I love the movie, I like the movie, right? And one time, like, so you can just like talk about, like you can see how these words are used out there. And once you have done that, we just save it to our word dictionary, and we save it to our SageMaker. And now we transform this review, right? We transform this review, and from it we create this array that I talked about, right? So all of these words, so you can see from this above trained data set itself, we have these different words from this all this big huge array that we have, and basically we're transforming these words into numbers, right? So we are transforming these words into numbers in a way, and like a lot of these functionalities are done within by PyTorch itself, the library that we use. So once this array has been created, then we upload the data to like our S3 bucket. So the S3 is basically the very same thing that I've been talking about that we use for to store our data. That's like that for people who've used web services. They have obviously used S3 bucket too, right? And then use save this train data set locally, right? And this is going to be a really huge data set itself. And you remember, you see this SageMaker sentiment.rnn. If you can see this previous that we have, training jobs, right? So basically, this is where like this gets saved as that, right? And this is what we like you reuse it later on. Like it was up there, but I'm sort of sorting the yes, this one. So this API that we like can use it in that, right? And no, that's this is basically the file itself that we use, and then we build and train our model, right? So we use this we call this, and then we use the PyTorch model to actually use PyTorch basically to read our training as CSV, right? And then we train our model. And when we train our model, like these are like the hyperparameters that you can actually tune, right? So like, for example, the LSTM classifier, you can use part of, like, for example, I've used it for like 10 iterations, right? So you can probably do this epoch for like 50 times or 100 times, and that's gonna probably give you a better output. You can actually test through it. This is what we call about parameter tuning. But also you can like, you should not like be overdoing it because it's gonna like overfit your data again, right? So underfitting if you do it for like 5 or 10, and overfitting when you do it for like 100 or 200 or 500 or 1,000, right? So you need to find that sweet spot where you actually want to do it. So there are different hyperparameters that you can like use to tuning, right? And then when we like train our model, and we are doing it for like 10 epochs, right? And see, we can see all of these. This takes a lot of time, right? And you see, the Amazon SageMaker actually bills you for the time that you trained your model for. So this is like for 295 seconds, and your model will, your system, like the Amazon will like charge you for this. And I use this P2X large thing, right? So this instance of Amazon SageMaker, that I use. If you use it for an hour or something, it's gonna charge you around $1.5, right? So training the model is not a cheap task, right? If you want an accurate model, if you want huge data sets, if you want to train it, you're gonna need a big resource, and it's gonna take a lot of time, and it's gonna charge you a lot, right? So making sure that you've got all of this machine learning workflow all together to use to minimize the training time and figuring out the sweet spot of hyper tuning and all of it. You need to like make sure how you can actually do it pre-thinking itself, right? And now once you've done this, we've trained our model. Now we test our model, right? So when we use it, so like this is, we are just splitting of the data set of for testing our model. And see, we've just like sent our new data to this prediction model, right? And when we predict, the accuracy is around 0.84, right? This is a really good accuracy uh, for for as of now. For this basically took like 295 seconds to actually train. So imagine when I talked about the different algorithms, right? So XGBoost is there, Naive-Bayes is there. You've got different algorithms. So what you do is you actually your model, train your model using different algorithms maybe, and find which one gives you the best optimum output, right? So there is the service on Azure that's called AutoML, right? So you can use different algorithms to train your models at once, right? And it's gonna show you which algorithm gave you the best accuracy. So you can choose that into your system, and you have to kind of make sure that the overfitting is not done either. So that is what you do by training, right? By testing, right? So you give new data to test it, and you can see how the results come up, right? And once you've done this, you can like just like send this data, and like you can find how it can be done. So basically what you do is this is basically the 0.86 accuracy for this very data that we send the simplest pleasures in life are the best. Like this is kind of positive, right? So from 0 to 1, it gives like around 0.8 cents of positive output, right? And you need to say like delete the endpoint. So basically, what you need to do is like if you're using these what you call our services or instances in Amazon SageMaker, you need to make sure that you delete if you're not using it, right? Because it's going to charge you for the amount of time it's on, not just big if you're using it, but also if you are just like if you have it on, right? So you need to make sure that you delete it if you are not using it. So that's really important, because if you are working for a company itself too, you might actually want to make sure that you're not costing the company much money, right? So just imagine if you leave it for like 24 hours, that's gonna cost like 24, like around 30, $40, right? And you leave it for a month and you just like forget it, right? Just imagine the $1,000, $2,000, what do you call it, the bill that's gonna come to your company, and like they're gonna ask you like, what did you just like do? And you're gonna forget it because you need to go to each of these services, right? Each of these services on Amazon, and you have to delete it, right? So for example, if you've got this service itself, you need to make sure that you go to Amazon SageMaker and you go on, and let's say, yeah, you go on and like you delete each APIs or the Lambda functions or all of these. So Lambda functions and REST API actually cost you less money, but all of these other resources from just the notebook that we used, this very notebook, this notebook instance, this is a different service within the Amazon SageMaker. You need to make sure that you click over here, right? Click over here, choose, and you stop it, right? Because this itself, this is MLT2 medium that I use. And inside this notebook itself, I use another 2 instances. So all of these are gonna charge you, right? So you need to make sure that you actually sort it down if you are not using it. So now next, when we deploy this model, like how do we deploy it basically? So we just like use the predict.py file, and this file actually we use it to deploy. And so what you see over here is we are sending all of these for testing. Like we have all these parts of testing our model itself, and we can find the accuracy by testing again, right? And how accurate our models. Like you can see above, we tested the data that's just inside, that was just inside the training model set, and we are training, like we are now checking the data from the testing model set. So we can see the accuracies are kind of similar, right? So this is kind of a good, because you are now sure that you are not just good at the accuracy of a model just from the data out there. So if new data has come up, you need to make sure that even those provide good enough results. So this is what I talked about in the presentation earlier. So the web app that we have are going to send it to API. The Lambda function uses it, and then the model is going to send back the data, and the app can use it, right? So now, if we want to like use the Lambda function, we have this Python code, right? So we create this Lambda function itself, and inside Lambda function, let's say Lambda. Okay. So inside Lambda function, when I showed you the result for this, so I actually created this Lambda function itself. And now on this Lambda function, this is the code that we had, right? So all I did was I used this endpoint from the notebook I had, right? So this basically the predictor endpoint. Now we are gonna get the endpoint. First of all, we get the endpoint from this notebook itself, and then we use this and add it to our, and we wait, where is it again? Yeah, we add it to our Lambda function, and this is the all that you need to add to this, right? And once you've done it, you test it, you deploy it, then you test it, and when you like when you're good enough with your results, so like if you got these outputs and all, then we actually go to create the APIs, right? So you click on create API. Then for now, if we are using the web app, you just create REST API, click on build, and then you go over and like create a new API, right? So send analysis, let's say 9, for example, let's say, right? And the API endpoint, we just keep it regional, new API REST, right? Create API, and then what you do is you just like click over here and create method, right? So this when we're taking the input from the website, it's basically the post, right? So we create a post one, and then we create lambda and use lambda proxy integration, right? So lambdas, you use this lambda region, and then we use let's say neural network, the lambda function that we use, right? So the lambda function that we used over here, that is what's this one, the sentiment analysis neural network. This is what we call in our lambda function. So we integrate this, right? And this is what we get, right? So this is the API gateway that we get. And this API gateway, once we save it, and this is what we are gonna use, and we are gonna deploy. And once we deploy it to, like, let's say new stage production, we do it like production, let's say production, and again, and deploy it. Now this is ready for use, right? So this is the API that we just like basically use in our yeah. So basically, if you can see this text on your web app, you just like use and paste your API gateways link to it, right? And when you just use it, you are good to go. And whichever like the website that you actually call upon, and so this form was the part of the website that was, and yeah, wait, where did it go? Well, because I cannot find it again. I cannot find the file here. But basically, you get the overall picture, right? So this is how you actually integrate the entire machine learning process from a service on Amazon, right? And you need to make sure that you use, if you are using Amazon SageMaker itself, you need to be using Amazon Lambda and Amazon API Gateway, because you cannot use third party in this case, because if you want to use Azure's service for this, at times this is not going to be able to integrate with that, right? So you need to see how these services are connected together, or if they are allowed or not. So if you can do that, you can actually complete the entire machine learning process on like you can get the grasp of the entire process of the machine learning, right? So that's how you do it. So yes, I hope you guys like the presentation, you've learned something, and if you have any queries, please feel free to ask me. Thank you so much.
Wow, nice. Thank you, Ojash. So it was a very knowledgeful and insightful topic, right? And I personally enjoyed your session, learning step by step that what are the things required to build a ML model. So thank you very much for the wonderful session. So we have now let's begin with a Q&A session. So I have a question with Sudeep ji. So if you see on the chat board, so someone has mentioned, does SDFS user commodity hardware like GFS used to? Is GFS is still used today? So if you can enlighten on that question, it will be
Yeah,
great.
Jay-Z. Let me see. Okay, Nimesh Gautam asked that question, right? Yeah, thank you, Nimesh. So by GFS, do you mean Google file system? I think you mean Google file system, right? So to answer your first question, does SDFS uses commodity hardware like GFS used to? So as Hadoop runs on commodity hardware, so does SDFS. So SDFS is basically an open source version of GFS. So the first folks who were to come up with a distributed file system idea were folks from Google. So as they were indexing the whole internet, right? So they had to come up with a solution to deal with distributed file system. So they developed GFS. They publicly released a research paper, right? So based on that, SDFS is based on that. So yeah. So as for is GFS still used? I don't know. Maybe Google uses it, but any offering of Hadoop that is from companies such as Cloudera or Hortonworks, SDFS is the default file system, distributed file system. Yeah.
Thank you, Sudeepji. So we have one more question by Sana Budin. So what is the roadmap to become a data engineer? If I only know SQL and basic object-oriented programming language, how can I move towards becoming a professional data engineer? So this question can be given by anyone. Was this Sudip? Sudipji?
Yeah, Ojash, you want to take it? Okay, let me answer this question. So basically, you need to read a lot, right? So that's a no-brainer. So read books about Hadoop ecosystem. So a book that I will recommend is called Hadoop, The Definitive Guide by Tom White. So yeah, you mentioned you have knowledge on SQL and OOP, right? So yeah, knowledge on SQL queries does come handy, not just relational database, but key value-based databases as well. So, but besides that, yeah, learn about columnar databases, like I mentioned in the slide about Parquet File, right? And also other databases such as Redshift, Snowflake, and learn about data mart, data warehousing, data lake. So those are the words that you need to put your focus on. How it works. First, you need to get the overview of how it works, what it is. Then only you'll be able to understand the ins and outs. Also, if you want to try Hadoop in your own local laptop, Cloudera provides an image that is VirtualBox image. So that's called Cloudera Quick Start. I think you can Google that and start learning Hadoop on your own local laptop. Yeah, I think that was helpful. Good question.
I would also like
So
to add,
JJ, yeah. So JJ, I see one question as well. Now that was asked by you. In case of streaming data, which data store is better, SQL or NoSQL? And how do we move data from staging DB to data lake? Okay, so this is also an interesting question. So usually for streaming data, when you talk about streaming data, let's say for example Twitter. So the data it produces is actually a JSON object, right? So those are unstructured, right? So traditional relational database have a fixed number of columns. So if you try to insert any data that exceeds those columns, right, you'll get an error. So traditional database won't work. So you have to go with NoSQL databases such as MongoDB or any other databases. Yeah. So I think that answers your first question. And about another one, how do we move data from staging DB to data lake, right? Like I mentioned in my slides, I mentioned the term scoop, right? So Hadoop provides a scoop. The scoop is the tool that is used to extract data from multiple databases. So Scoop also supports a lot of database drivers. So it is able to connect to any databases, whether it be relational or key value-based databases. So during each connection, it uses different specific, database drivers. So based on that, you can extract data from any sources. So that's how Hadoop
Thank you.
comes handy as well as Scoop.
Thank you, Sudipji. So there is one more question by Nimesh Gautam. How can I get access by AWS service from Nepal? Can we use $car or is there is any way? So as for my information, I think you can contact to Genie Solution. So they are basically dealing with the AWS. Yeah, you can get with us on Genie Solution for the AWS credit. And there is one more question. Why should we use AWS or paid service instead of Google Colab?
oh yes,
So
so
yeah,
regarding
this.
this, so basically these two are like kind of competitors in itself. Like let's say Amazon ko SageMaker ra Google Colab are kind of competitors in a way, but it really depends upon the company that uses to, right? So if your company actually are full-fledged using on AWS itself, you would not be interested to be using the other service, right? If you're using AWS itself, you would not be in tune to use Azure maybe. So you see all of these services, like let's not just talk about Colab or AWS itself. Even Azure is there, IBM is there. So different services are there. A lot of preference can come from the corporate settings too, right? And from what they've been using, and also from the resources of or let's say the previous engineer that were there, because the stacks it's already been used in that particular technology. It's difficult to move around, right? And if you're using AWS itself, it actually fulfills all of your needs, right? So you would not need to use anything else, because AWS is basically the king of cloud computing, and whatever service you want, it's out there in AWS. So why would you not use AWS itself? It would be a question itself. But if you're using Google Cloud itself, it's a pretty good technology, and it's a pretty good technology itself, and it's a good service itself. So you can actually probably explore both of those at time and see what you prefer, right? So you see, if you use Azure, then you've got different services such as the um, automated ML that I talked about, right? You can run all of these different algorithms to and train your model at once and get an output, right? So that's not there in AWS. So you see, all of these services have some pros and some cons. I would not particularly say use AWS itself or use Colab or use Azure itself, but obviously it's good to be known to technologies, and it's fun to test around, right? So AWS obviously gives you like a free 1 year thing, and a lot of services on AWS is also free if you are just signed up for the first 2 months or for the year. So you can play around with for the service that are that do not cost much, and the services just as this the that I talked about, the Jupyter Notebook and all the services on a lot of services in Amazon SageMaker. Those are the notebook itself can be run in a very small instance that will not charge you much. But if you are using the trained models like that, and then you have to create a new instance for it, which needs to be like a bigger instance. That's when you get charged more. So it really depends upon your preference and where you are from, where you are at right now, and things like that. Thank you so much. I hope that cleared a question.
Thank you, Ojash.
I would like to add something on that. So yeah, Nemes, I think what you meant is why should we go for paid services instead of freely available ones, right? So Google Colab or Kaggle, for example. So just to note that is when you use GPU in Google Colab or Kaggle, so the performance is limited. Also, in terms of Kaggle and Google Colab, the behavior of Google Colab is a little weird. So if you max out your GPU usage, right? So it abruptly ends up your session. So also in terms of Google Colab and Kaggle, the session time limit is 9 hours. If you train your model, let's say you do hyperparameter tuning, right? So that will take a lot of time, maybe more than nine or more than a day. So in that case, that won't be applicable for you. Your session will just stop. Yeah.
Okay, thank you, Sudipji. So I have one more question. So this will be the last question. So as you have talked about the pipeline, right, about the data tier. So which cloud provider you are using for building the pipeline? Are you using the AWS or Azure or other cloud provider? And what will you suggest to which cloud provider to use for the operation?
Yeah, to answer on that, when we deal with healthcare data, we have to work. I mean, we are obliged and we fall onto a lot of compliance. I mentioned earlier about HIPAA, right? HIPAA. That compliance, what it dictates is healthcare data should not be misused or it is let's say it is too risky to use any other cloud services outside of your organization. So what we do is any data analytics company, they have their own on-premise servers. But recently what I noticed is AWS provides a HIPAA compliance as well. So I think most of the companies dealing with healthcare data, they are using AWS as well, I think, because I read in AWS website that they now provide HIPAA compliance. So yeah, but for our company, we use all of the services are on-premise, and we use Cloudera for a big data platform. And yeah, I think that was helpful.
Okay, thank you, Sudipji. So basically now we are closing the session. It was a nice presentation from Sudipji as well as from Ojash about the topics which we have talked. So thank you, participant, attendees, uh, to be still till 9. Sorry, not 9. It's 7:30. So thanks for your patience to listen the topic. And so just wrapping the session, so I like to thanks to our supporters Microsoft and our media partner Living with ICT. So with their support, we are conducting the session on the regular basis, on the monthly. So for the upcoming session, we are doing on machine learning. So I hope your presence will be also there on March 27, 2022. So that will be on Sunday. Thank you for that one. And lastly, I want to thanks to Sudipji as well as to the Ojash for coming on TechWebinar Nepal Series 40. Thank you very much, and and thanks for your time.
Thank you
So
so
thank
much.
you all. So we will see you on TechWebinar Nepal Series 41. Good night. Stay safe. Thank you.